In object-oriented programming, objects usually refer to bundles of information. For example, you can describe a car as having number of wheels equals 4 and license plate equals 4BIU011. And this bolus of electronic information represents the physical entity in a computer. In this course, we will use objects to describe the chemistry, design, and simulation concepts associated with genetic engineering. Many common programming languages have some notion of objects, including C++, Java, JavaScript, Python, JSON, and XML. However, they behave differently in different languages. In some languages, their behavior really is restricted to just holding the state of some data fields. In other languages, objects can have fields that execute functions. Some languages, like JavaScript and the related JSON, have dynamic objects in which the fields can change, while others are strictly declarative of their fields. For our purposes in this course, we will not need this dynamic behavior. However, I will use JSON because it is simple. Let's look at an example. An email is a piece of electronic information. You have a concept in your mind of an email. You can print out the email, and then it has a physical representation. The email is an object. There are many trillions of instances of emails. However, they all have the same structure. They all have to and from addresses, a subject, and a message. I can represent this bolus of information in JSON. The syntax for representing an object in JSON is to put it in set brackets. The many fields of the object are separated by commas. Each field of the JSON is described by a key, such as to, from, subject, or message. The key is surrounded by quotes, followed by a colon, followed by the value. So the value associated with the key to is hiring at 123publishing.com. The value can be a string, a number, a JSON object, or a JSON array. These JSON arrays are lists of other values, and arrays are expressed as an ordered list of values separated by commas and surrounded by square brackets. So for example, a list of color names would be represented by left bracket, quote red, quote blue, quote green, right bracket. One example from the domain of biology is that of a feature. In APE, you go Features, Edit Feature Library to see your features. And you get this GUI that shows the names of the list of features. You can double-click on the name to get a description of the contents of the feature object, such as its name, its sequence, its colors, etc. We can represent this feature in JSON by describing it as an object composed of fields described in key value pairs. Those keys are name, sequence, forecolor, and so forth. We could express the entire list of features described in APE as an array composed of multiple JSONs. Let's examine the similarities between different objects here. They all have the same list of keys, but the values are different for each instance. The pattern shared between similar objects defines a class of information, and this similarity is defined by the list of keys they all share and constraints on the values permitted for each field. You call the entity that describes this form of the data a data structure, and specific languages will refer to it as a class or schema. It represents the structure of the data. I can encode this data structure in the form of a Java class. The class states the list of keys and what type of value they contain. This specific piece of information about the beta-lactamase feature, when held in memory as a Java object, is referred to as an instance of the class called feature. Going back to our email example, we can now describe the data structure present in the email object as an email class. Another essential concept in object-oriented programming is that classes can have inheritance. Our email class is very general. It just encodes the bare minimum information that all email messages share. If I was to restrict the objects I am describing to just Gmails, I'd undoubtedly find all sorts of additional information that all Gmails have, but other types of emails such as Yahoo or Hotmail don't have. I can capture this relationship between the Gmail and the more general email by saying that the Gmail extends email. By stating that Gmail extends email, we are saying include everything you had in email and then add this other data to it. So for example, there might be routing codes or various types of attachment that would be included in the Gmail class but not present in this root class we call email. In Java, there are two types of inheritance. A class can extend another class or implement an interface. A class can only extend one parent class, however, it can implement any number of interfaces. An interface is like an abridged version of a class. The fields in a class can refer to both pieces of data, like a string, or methods that do actions. An interface is only allowed to encode the methods. You can distinguish a method from data in Java by looking for parentheses following the field name. So for example, if you write string get2 without parentheses, this would refer to a string whose field name is get2. While if you expressed get2 left parenthesis right parenthesis, this means a method that will execute when run and return a string. Additionally, all the methods defined in an interface are abstract, which here means that the body of what you do when the method is invoked is not defined in the interface. The interface is simply a promise that this method will be concretized by any implementing class. So we can express the same concept of an email object in terms of an interface in which we promise the strings of 4 types will be made available by any implementing class. We can then describe the Gmail class as implementing email and providing methods that will satisfy the generation of these returned strings. In summary, objects describe a bolus of information. Classes or schemas describe the structure of information in an object. Classes standardize information. Inheritance somewhat means take everything about this other class and then add this additional stuff to it. In Java, inheritance can be achieved by extending classes or implementing interfaces.